Hello students, you must have heard about the renewable and non-renewable energy resources. As we need secure and reliable energy supply 24 hours a day, we should use more and more of renewable energy resources like solar and wind, and also to reduce our reliance on non-renewable energy resources like oil and gas and some fossil fuels. But it's not so easy to just switch over to using renewable energy resources 24 hours a day. It becomes a necessity to store energy generated from these renewable energy resources in some powerful, reliable batteries. So I'll be taking up the topic of batteries in the upcoming episodes, and in this episode I will be discussing about the basic concepts of battery, how it was invented, its construction, components, and classification of batteries with some examples. The main basic unit of a battery is an electrochemical cell, which converts chemical energy into electrical energy through an oxidation-reduction reaction, that is, redox reactions. These type of reactions involves the transfer of electrons from one material to another through an electric circuit. Though we are referring to a term battery, the more basic term is a cell. So, a battery can consist of one or more than one cells connected either in series or in parallel. Battery can come also in various shapes and sizes according to their application in different sectors. It is very handy and convenient to use as small as a fingernail, or it can be as big as a trunk. Before going into deep in the topic, we should know how it was invented and what are the different milestones of the battery. Initially, in 250 BC till 224 AD, Parthian Empire was using a clay jar, inside which a copper rod was immersed in a vinegar solution. They were using this clay jar for electroplating of gold onto silver artifacts. Later, it was identified as a battery, and hence it was known as Baghdad battery, as it was used in Baghdad, and also Parthian battery, as it was used by Parthian Empire. But the term battery was first used by Benjamin Franklin in 1749. Afterwards, in 1800, Alessandro Volta invented the voltaic pile, which was also referred as a battery. In 1859, the first rechargeable, that is a type of secondary batteries, lead acid battery, was developed by Gaston Plante. Then in 1868, a modern zinc carbon battery, also known as Leclanche battery, as it was developed by a scientist, George Leclanche. Nowadays, what we are using, that alkaline battery or lithium batteries in various remotes, computers, telephones, mobile phones, or in some other applications of toys, either alkaline battery or lithium battery was invented by Louis Urey in 1949. Now, let us move forward to construction of a battery, how it was constructed, or we can say how can we construct a general battery. There are various parts of a battery: cells, then to connect cells, cell connectors, then plates, to differentiate the plate separators, then electrolytic solution, and to cover all these materials, case, cover and vent caps. As I have discussed, we can see in this diagram, there are various parts. Number 1, the case to cover all these materials, the cover to hold the material, then separators to separate electrodes, cell connectors, cells, plates and electrolytic solutions, and overall the vent caps to release gases. The main basic unit of a battery is a cell. Cell is consisting of both the electrodes and separators. As I have already told, cell can be one or more than one in a battery. But a single cell produces about 2.1 volt when immersed in an electrolytic solution. In a battery, if we are using more than one cells, then a heavy metal cast alloy straps are used as cell connectors to connect all these cells together in one battery so that they can work simultaneously either to increase voltage or to increase current as per their application. Then the plates. In a cell, we are having two types of plates, positive plate and a negative plate. That is, we can say cathode and anode. Both the plates we can say form of either metal or metal oxide. But if we are talking about positive plate, then they will be of positive metal oxide, and if we are talking about anode or negative plate, then that it will be of metallic or alloyic plate. Then these plates are separated by a thin porous semi-permeable membrane which allows only selective ions to pass through. After that, these plates and separators are dipped in an electrolytic solution. These are chemicals or mixtures of chemicals which react with the active materials in the plates to create an electrical pressure, or we can say voltage, and conduct the electrical current. This electrolytic solution can be any solvent, or we can say water mixed with salts, acids or alkalis, mainly to impart conductive current. Then vent caps. Vent caps are on the vent holes. They allow mainly the controlled release of hydrogen gas during charging. During charging, the hydrogen and oxygen gas, both the bubbles come out from the vent holes, which can be capped by vent caps to controlled release. All these materials, that is electrodes, separators and electrolytic solution, are held and protected by a case, that is a container type, and cover provides outlets for terminal posts and vent holes for venting of gases and for battery maintenance. By this time, we may have understood the basic components of a battery, that is anode, cathode and electrolyte solution. Now anode. Anode, or we can say negative electrode or negative plate, they acts as reducing or fuel electrode. It gives up electrons to the external circuit and is oxidized during the electrochemical reaction. It can be any metal or any alloy, but hydrogen can also be used as an anode. Now cathode, it acts as oxidizing electrode. It accepts electrons from the external circuit and is reduced during the electrochemical reaction. It can be any metallic oxide or sulfide, but oxygen can also be used as a cathode. Now the electrolytic solution. It acts as ionic conductor. Electrolyte solution provides the medium for transfer of charge as ions inside the cell between the anode and cathode. It is typically a liquid, either water or any other solvent mixed with salts, acids or alkalis to impart ionic conductivity. The electrolytic solution can never be a conducting one, so that it can never discharge when not in use. So, electrolytic solution, whatever the type of solution is, either alkali or acid or any salts, but it should be non-conducting. As I have already discussed, anodic materials, cathodic materials and electrolytic solutions, these are some examples. The best negative nature of the material, the best quality of the anodic material. So, for example, lithium, magnesium, aluminium, zinc or chromium, they are having very high negativity nature. so they are characterized as best anodic materials. On the reverse order, if we are saying for cathode, the highest positivity of the particular material, the best category of the cathodic materials. So we can say like iron oxide, cuprous oxide, iodate or ferrate, these are having very high positive nature, so they can be considered as very good cathodic materials. But for electrolytic solutions, it can be any solvent either mixed with salt or acids or alkalis. So, potassium hydroxide, sulfuric acid, salty water and lithium iodide solution. These are some more familiar examples of the electrolytic solutions which we are using in our day-to-day life in batteries. Now, if we are using a battery to store energy, then we will use it somehow anytime. If we are using a battery, then it will get discharged. And after discharging of a battery, we will again try to recharge it, or we will try to first recharge of a battery before using it. So what is discharging and what is charging? Discharging, when any external load, like you can see a bulb in this diagram, is connected to the electrodes, these are two electrodes, oxidation reaction starts occurring in one electrode and on the same time reduction is occurring on other electrode. As you can see in this diagram, on the one plate oxidation is occurring as ions are going through it, and on the other electrode reduction is occurring, that is electrons are giving up from this electrode. And this will continue until and unless the metals become alike and the acid, that is the electrolytic solution in the container, is used up. As you can see in this diagram, it is a diagram of charging. We will discuss it in the next slide. During charging or recharging, the current direction is reversed. That is, if reduction reaction was occurring in cathode initially, now oxidation reaction will occur in this cathode, and in this anode oxidation reaction will occur in discharging, but now reduction reaction will occur in this anode and the current direction is reversed. We can say the voltage is applied. So during charging, the current direction is reversed and oxidation takes place at positive electrode and reduction at the negative electrode, and it will continue until and unless the cell materials are restored to their original conditions, that is the cell or a battery is fully charged. For charging of particular battery or a cell, there are mainly 5 factors which have to be considered: temperature, state of charge, plate area, electrolyte impurities and gassing. Temperature. If we decrease the temperature, it will resist the charging. So, as you have already seen in your day-to-day life, if the battery is cold, it will take longer time to charge, while warm battery will take less time to charge. And never ever even try to attempt charging for a frozen battery, it can never charge. Now the state of charge. State of charge means the capability of all the selective atoms, that is active materials, affecting charging of particular cell or a battery. Now plate area. If we are increasing the plate area, it will take longer time to charge a battery. So we can say lesser the plate area, lesser the time for charging. Next factor is electrolytic impurities. As this is the common thing, if impurities are more, any property will discard it. So we can say if impurities are more in electrolytic solution, it will take longer time to charge, or in other words, electrolytic impurities resist charging. The last factor to be considered is gassing. As I have already told before in previous slides, that both the electrodes, that is cathode and anode, provide hydrogen and oxygen bubbles while charging. If these bubbles or gases come out through vent holes, these are the vent holes, they will also wash away the active materials of the electrodes, and that will affect charging and it will take longer time to charge. Now the characteristics of battery. As I have already told before, it can vary in different sizes and in different shapes. So, like physical batteries, it can be of button shape or AAA shape, AA shape, And the most important term, energy density, that is the capacity of that particular battery per their size, either in volume or in weight. If you are talking about weight term, then the more specific term is the specific density, and if you are talking about the volume, then it will be considered as energy density. But for a battery characteristic, we more generally use energy density for both the terms. Next is longevity, that is how long a battery can work according to its capacity and its number of recharge cycles, that is up till a number of rechargeable cycles a battery can work for a particular application in particular sector. And then discharge characteristics, that is a voltage drop. Next characteristic of a battery is cost. Then there are some behavioral and environmental factors which have to be considered for a battery, like more commonly temperature, as I have already told before in factors for charging that temperature affects charging. Then self discharge, as I have told in electrolytic solution, if the electrolytic solution is conducting one, then it will get self discharged. The memory effect of a battery, and some environmental factors include leakage, gassing, toxicity and shock resistance of a battery. Now the classification of batteries. Batteries can be classified mainly in 4 types: primary batteries, secondary batteries, reserve batteries and fuel cells. Now the primary batteries. Primary batteries are very easy to use and very convenient. They can be easily sized and shaped in any size and in any shape according to their applications in different sectors, in different tools, toys, cameras, etc. Then secondary batteries. These are rechargeable batteries, and nowadays you have seen a rechargeable battery used in some toys, in some games or in camcorders or in telephones also. Now reserve batteries. They are high power source of batteries. They are mainly used in weapon system, that is in fuses or missiles, where we need to have a high amount of power for generally a shorter period of time. Fuel cells. Fuel cells are mainly a type of battery in which we are using an open source of air and an open source of material, that is a solution. In all these 3 types, primary, secondary and reserve, we are having a limited source of solution, that is we are having particularly a limited solution and electrodic material within a battery. But in the fuel cell, it is an open source, that is open source of air, that is oxygen, and an open source of hydrogen which is connecting through a fuel cell. Now we are taking up the primary batteries in detail. It is non-rechargeable, as I have already told, and disposable ones. If once the chemical reaction is used up in the particular battery, it can never be reversed in primary batteries, whereas it can be reversed in secondary batteries, as we will discuss it in the later slides. For the longer period of storage, we generally prefer primary batteries, and it also having a lower discharge rate as compared to other type of batteries. Some common examples of primary batteries include alkaline battery, Leclanche battery, because it was invented by Leclanche, or zinc carbon battery, magnesium batteries, aluminium batteries, mercury oxide batteries, silver oxide batteries or lithium batteries. Now the secondary batteries, as I have already told, these are rechargeable batteries. They can be recharged number of times as per their capacity of the application. These are similar to primary batteries in all concepts, except once the chemical reaction occurred in a battery, it can be reversed number of times according to its capacity, but it can be charged through a specific charger only, and they are having better low temperature performance and very low maintenance is also required. Some examples of secondary batteries include lead acid batteries, nickel cadmium battery, nickel zinc battery, nickel hydrogen batteries, nickel metal hydride batteries, silver cadmium batteries, silver zinc batteries and lithium ion batteries. We will discuss lead acid batteries and lithium ion batteries in detail in my upcoming episodes. Now the first example of primary batteries, that is the alkaline batteries, which you have seen in many applications like in your quartz watches or in your calculators or in remotes. We are using mainly alkaline batteries. The name alkaline comes from the alkaline nature of an electrolytic solution which we are using in these type of batteries. In this type of batteries, the anodic material is zinc powder form and the cathodic material is manganese dioxide, that is MnO2. And the electrolytic solution we are using is potassium hydroxide. So the overall reaction of this type of battery is when zinc in solid form reacts with manganese dioxide, which is again in solid form because they both are in electrodes, forms zinc oxide, that is at anode the oxidation reaction occurs, so it will form zinc oxide, and in the same time reduction occurs in the cathode, so it will form Mn2O3 in the solid form again, as they both are in electrodes only. And the ions are conducting through an electrolytic solution which is conducting voltage, so the electric voltage which is conducted was plus 1.43 volts. If we are considering the half reactions of anode and cathode, then at anode zinc, which was initially present, when reacts with hydroxyl ions produce zinc oxide and water, and 2 electrons are removed. At the same time at cathode, these water and 2 electrons which we are giving up from the anode reacts with cathode and then forms Mn2O3 and 2 hydroxyl ions, and these 2 hydroxyl ions again in the electrolytic solution which will again reacts at the anode, and this will continue until and unless the metals become alike of the anode and the cathode, and the electric voltage of anode and cathode are respectively minus 1.28 volts and plus 0.15 volts. Now the advantages of alkaline batteries. They are having a high capacity as compared with other type of primary batteries, and they are very suitable for high drain rate applications. They are having a very good shelf life, and they can come in variety of sizes and in variety of shapes, and low temperature performance. They are having a very good performance, and also a high rate performance of alkaline batteries is there. Whereas if we are talking about the disadvantage of alkaline batteries, they are having a moderate cost but most cost effective at high rates. As we can see in this diagram, this is a positive terminal of a battery. We are having a cathode of manganese dioxide as we have discussed, then anode of zinc in powder form, and we are having this is a negative terminal through which we can connect it through other cells, and this is a current collector, and we are having electrolytic solution of potassium hydroxide and water, that is a solvent or a water mixed with any salts or alkalis or acids. Now the second type of primary battery is zinc carbon battery. It is first invented and patented by Georges Leclanche, and hence it was also known as Leclanche battery. In this type of battery, the anodic material is zinc in a metal body form, whereas cathode is of manganese dioxide, and the electrolytic solution is a paste of zinc chloride and ammonium chloride dissolved in water. So the overall reaction of zinc carbon battery is when zinc in metal form reacts with manganese dioxide again in the electrode, and ammonium chloride which is present in electrolytic solution gives Mn2O3 and zinc, and also NH3 whole twice chlorine plus water in the liquid form. Both these solutions, water and NH3 whole twice Cl2, both will come in the electrolytic solution, whereas zinc and Mn2O3 both will be the electrodes, and the electric voltage of this whole reaction is 1.3 volts. If you are talking about the half reactions at anode and cathode, then at anode when zinc reacts at the anode, it will form zinc in ionic form and 2 electrons, and the electric voltage will be minus 0.763 volt. Now at cathode, when ammonium chloride reacts with manganese dioxide, that is NH4Cl, when reacts with MnO2 and 2 electrons which came from anode to form Mn2O3, water and ammonia and chlorine. Now the advantages of zinc carbon battery. It is of very low cost. It is very good for non-critical use under moderate conditions. Again, as it is a type of primary battery, it can come in variety of sizes and shapes, and it's very available in all the forms, and it's having a long tradition of reliability. Whereas if we consider the disadvantages of zinc carbon battery, the main disadvantage is it is having a propensity to leak. It's having a very low energy density, very poor low temperature performance and poor shelf life. What we have discussed for zinc carbon battery can be seen in this diagram. A carbon rod, they are having two terminals, positive and negative terminals. Then protective coating is there, then pitch seal, air space, then manganese dioxide mixture is there, then electrolyte paste is there, and zinc which is of electrode and separator for separating electrodes. So in this lecture we have discussed about the basic concepts of battery, how it was invented, its construction, components and the classification with some detailed view of examples of primary battery. In the upcoming lectures, we will be discussing about some examples of secondary batteries, fuel cells and power batteries, about their principle and construction also. Thank you.